There is only one perfect solution, but there are clues that will try to trick our team.
Hello there everyone, my name is Crazy Caleb and welcome to Generated Maze. This is the way the module looks. What we have here is we have a color and a shape that will be present, and this will represent where you currently start at. And what our goal is to try and find a solution that we're going to be submitting here. And the way that you're going to do this is a little bit interesting, and it's not going to be the most creative maze ever because it's going to be generated. So let's get into how we actually have to do this. So currently, one thing that I should also mention is that these walls currently that are like you can highlightable, these will always default to being filled in. White will represent not filled in, and these will represent traversable tiles that you can go from one space to the next. That's going to be very important to note because of the fact that that's going to be relevant to the calculations of the goal row and column later on. So let's get right into this and let's see exactly what we need to do here. Okay. So, to solve the module, the diffuser must reconstruct the maze and move to the goal square. Moving into a wall, attempting to move off the maze, it does not move around by the way, or submitting an incorrect configuration will cause a strike. So, now, for each internal wall, calculate its value by adding the value of the adjacent squares, whose value is found by adding the column variable to the row number, with A1 being top left. Okay, let's slow down here for a second. So, what we have here in the bottom of the manual here is we have column variables. And what's going to end up happening here is we're going to get a series of different column variables. And what these are going to represent is these are going to represent additions of where you're going to essentially, for each row number, you're going to add that number. You're going to add that number in that column. Hopefully that makes sense. So let's actually determine our column variables because these will always be constant values. These will always be the exact same. Number of batteries is going to be a 2 here. What Bravo and Delta represent is these actually represent the color and the shape of the actual of the player in this case. So in this case, we're currently a green and we're currently a plus. So that's going to represent 1 for Bravo, and number of core plates is going to be 1, 2, 3. Next up we have 2, and the number of indicators we have here is a 1. Okay, now. One thing I'm going to immediately mention is that any value for this maze that goes above 3, it will be moduloed by 3 because this is how we're going to be determining a walls. This is going to be how we're going to determine the walls essentially. So everything will be moduloed by 3. So effectively, what I mean is this Charlie value for the column C is this is going to be immediately going to become 0. And now essentially what these represent is now what we're going to do is we're going to add the value of each of the positions in the rows, in this case, starting with alpha 1, 1 being the topmost tier, 2, 3, 4, and 5, respectively, afterwards. So what we're going to do is we're now going to do 2 for each of these guys here, and remember we're going to modulo 3 for each of these values here. So it's effectively going to become 0, 1, 2, 0, 1. And that's going to be the way that this column is shaped here, because essentially what we're doing here is writing 2 plus 1 for this row, in this case for this column, 2, and then row 1, and then that's going to be moduloing it by 3, which will give us a result of 0. Next up, we're going to be doing 2 plus 2, which is equal to 4, in this case the second row, and that's going to be equal to 1. And as you can see, essentially what's going to happen here is that it's just going to be adding 1 each individual time in the maze. So that's going to be the way that this works. It's going to be adding 1, and then if it happens to reach 3, it loops back around to 0. So effectively what's going to happen here is we have 2, 0, 1, 2, 0. Then we're going to do 1, 2, 0, 1, 2. Then we're going to do 0, 1, 2, 0, 1. And we're going to do 2, 0, 1, 2, and finally 0. That's the way that this is going to work. Because remember, we're adding the value of the column variable to the row number. And these are the way that these values are going to be determined. So now, what we need to do is we need to figure out how we calculate the internal walls. And we're going to calculate its value by adding the value of the adjacent squares, whose value is found by adding the column variable to the row number, which in this case we've determined. Now, effectively what's going to happen here is if the wall's value is congruent to 0, in this case it's equal to 0, modulo 3, it should not be filled in. So what this effectively means is that when we happen to have a case where and adjacent where two adjacent positions will happen to be equal to 0 after you modulo by 3, what's going to happen is that you're going to mark this white. It should not be filled in, therefore it is not a wall. So immediately one of the first things that we take a look at here is these two positions, in this case Bravo 1 and Charlie 1, the adjacent tiles between each other, in this case 2 plus 1, add up to 3, modulo by 3 is equal to 0. And in this case, this means that this wall will not be filled in. It is no longer a wall. Next up, 1 plus 0 is going to be 1. That's going to be filled in. And immediately one of the things that you can already tell is the only cases where this actually applies is if it's either a 0 and a 0 adding together, or if it's a 1 and a 2 adding together in some way, shape, or form. That's going to be the way that you're going to determine whether there is a wall there or not. And there won't be a wall if these cases apply. And in this case, it's actually going to be pretty easy to spot for some of them. So let's move this guy over here. So this 1, 2, and 1 here is going to be right here. Now, also 1 and 2 in this case in the Charlie column here, this is not going to have a wall between it either. There we go. So next up, and it's actually going to be kind of going in a zigzag fashion. So this is actually going to make it a little bit easier for us to do. So 1 and 2 right here represents the wall in between. Represents no wall in between them because they add up to 3 modulo 0. Modulo 3 is going to be 0. 2 and 1 is going to be no wall. 2 and 1 is going to be no wall. Now let's go over here. 2 and 1 is going to be no wall. 2 and 1 is going to be no wall. No wall. No wall. No wall. And no wall. Just like that, we have determined part of our maze here. Let's just make sure that we have a basic rundown. Let me make sure I didn't forget anything else. 2 and 1. Yeah, I think that looks pretty good. So now that we've determined how the maze actually looks and the way that the walls are, remember the walls are being black here, what we're going to do now is the goal row is congruent to the number of filled walls in the final maze, modulo 5 plus 1. So now what we're going to essentially do here is we're going to count all of the maze parts that are black in this case. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. It should be 28, I believe. We're going to modulo this by 5, which in this case, 28 modulo 5 is going to be equal to 8, which is equal to 3. Adding 1 to this is going to be equal to 4. This is going to represent the goal row. Okay. Now, let's see what we need to do for the column here. So we don't know exactly what the column is going to be. All right. The goal column is congruent to the total number of totally isolated cells. Cells which have 0 legal moves, modulo 5 plus 1. And by the way, I should mention, the outer edges of the grid will not change anything because there's exactly 5 walls on each edge. So therefore, it doesn't matter. But now, here's something that does matter. So now what we need to do is we need to count the totally isolated cells. And remember, this does not loop around. So we have quite a few here. We've got this one up here, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So now we have a total of 11, and we're going to do the exact same thing, modulo 5 plus 1, which in this case is going to give us a total of 1. Adding to that is going to be 2. In this case, we can convert this to a Bravo here, Bravo 4. Bravo 4 is going to be our submission point, and now what we simply need to do is we simply need to navigate to that position, and as you can see, one of the immediate red flags that you're going to get if you happen to have a correct answer or not is if it's actually reachable from our current position and based off of the walls that is present in the maze. In this case, Bravo 4 is indeed present, and it is indeed actually able to be reached from our current position. So if we were to go up and left, we would then reach Bravo 4, hit our submit button, and just like that is a solved module. It's a fairly simple module, but you definitely need to read a little bit and need to understand how the column variables actually work. This bit is extremely important, as well as understanding how the walls work. And remember that white represents no walls and black represents walls. It always defaults with walls first in the beginning of the module. That's just to make it easier for you, because there's going to be more walls than there will be unfilled. So let's take a look at one more example. Excuse me. Anytime now, game. Okay, let's take a look at another one here.
There is only one perfect solution.
So let's determine our column variables here.
Trick our team.
Number of batteries is equal to 1. We have red and the plus again, so we've got red and plus. So red is going to be equal to 3, modulo by 3 is going to be equal to 0. And that's what I mean. You can just simply make it easier on yourself and just modulo every single column variable by 3 because of the fact that it's going to be essentially adding here, that we're going to be doing stuff with 3. Number 4 plates. We've got 1. We have 2 for the plus, and number of indicators is going to be equal to 0. Okay, good. All right. Now let's get graphing this grid here. So we have we've 1 as our column variable, so we're going to start with 2 for this column. So 3, 0. Then we've got 1, 2, and then a 0 here. Next up, we've got 0 for column Bravo here. We've got 1, 2, 0, 1, 2. And then we have 2, 0, 1, 2, 0. As you can see, it's quite simple to do. 0, 1, 2, 0, 1. And finally, 1, 2, 0, 1, 2. There we go. Now, let's determine which walls should not be filled in. Remember, we're looking for 2, 1 in some way, shape, or form, or 0, 0. And in this case, as I can already tell, there is no 0, 0s present in this grid, but there is a lot of 2, 1s that we can actually absolutely mark off here. So this one right here, this one right here, this one right here for that little bit right there. Okay, it appears to be going in a zigzag form right here. Okay. I believe that actually looks like that's it. It's not quite though, because we have these 2, 1, and 1, 2. It's very important that you do everything in this case because of the fact that it will affect your goal position. Okay, let's take a look and let's see if there's anything else just to make sure. And that actually looks like that's going to be it. Perfect. So now let's start determining our goal here. So our goal is going to be trying to figure out the filled walls. In this case, goal row and goal column. So let's figure this out. So filled walls in the final maze. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. 26 is going to be equal to 1 after the modulo 5, and then we're going to add 1 to this. In this case, that's going to give us 2. So now, let's take a look. We do have 2 possibilities for row 2. That's looking good so far. But now what we need to do is we need to determine whether we're looking at delta or echo in this case, 4 or 5. So now, let's take a look at the totally isolated cells. We have 1, 2, 3, 4, 5, 6, 7, and 8. 8 modulo the 5 is going to be equal to 3, plus the 1 is going to be equal to 4, which in this case is going to be delta 2. Delta 2 is going to be our answer. We're going to simply move left 1 space, and just like that is a solved module. As always, thank you guys for watching. Remember to stay crazy, stay cool, and I will see you in the next one. Bye-bye.